Here we're dealing with more problems that work on the commutative property that tell us look for ways to switch the fraction around to make your life easier. So I'll put a couple on here. We have 2 over 5 times 5 over 9. And then we have 3 over 7 times 7 over 9. And we can use the standard algorithms, multiplying our two numerators, which is 2 times 5, and our two denominators, 5 by 9. That gives me 10 over 45. But of course I could reduce that. I could divide 10 and 45 by 5, and I would get 2 over, what, 9, right? Here, I can multiply the numerators, 3 by 7 over 7 by 9, and I get 21 over 63. And if I reduce that, I can divide the numerator and denominator by 7 to get 3 over 9, right, which is 1/3. But instead of working with all this stuff right here, right, which is not that difficult but does take time, how can we manipulate this problem to make it easier? Because really, this is about efficiency, not just working your way through it, but being efficient. If I notice that I have a 5 here and here, if I switch the two numerators, which we've talked about in other videos, will not change the value of the problem, just the way it looks. This will help us see the answer. And all I've done there is move this numerator here and move this 2 here. Because these two 5's match up, if I put one over the other, that means 5 divided by 5, which is just 1. Right? That's 1. And 1 times anything, 1 times 2/9 is just 2/9. So by switching on these two numerators, we can see that the answer needs to be 2/9. And the same thing is true here. If I switch the 7 with this 3, these two 7's will be right above each other, which means we'll have 7 over 7 times 3 over 9. And that's like having 1, right? 7 divided by itself is 1, times 3 over 9. Well, that's just 1/3. So it's 1 times 1/3. And that gives us and matches the answer we got before. And if you want to go back and look at 2 other videos, the rectangular arrays show us why this makes sense. Basically, like in the first problem, it would show us a 5 by 9 area, because it's fifths times ninths, right? This is for the first one up here. If we multiply 2 by 5, the numerators, we might generate a rectangle like this, 2 by 5. But if we multiply 5 by 2, we would just get something like this. The blue and red rectangles have the same area, they're just in different directions. So when you switch numerators, you're just changing the direction of your shape, not the total area. And here we're concerned with the product, or the area of the two numbers. And I think you might recognize that 2 times 5 is 5 times 2. And that works even with fractions. So look for ways to be efficient.